Hi, good morning, everybody, and welcome to today's webinar on BIM workflow, which has to be utilized at different stages of a plant project lifecycle. In today's presentation, we will talk about how do we utilize BIM from the conceptual stage to the modeling stage, and then going up to the stage of optimization and coordination in this case. My name is Preeti, and let's see how we move across in the webinar and we talk about the different aspects of our projects basically. Before we start up, I would like you to take a quick review on a safe harbor statement and whatever content which we talk about in our today's presentation, which I'm supposed to share, is totally confidential and it doesn't constitute any formal notification. And in case if you want some formal notification with the program details, etc., we'll share more details in our upcoming webinar sessions in this case. We also have a poll session, which is supposed to be done at the end of my webinar. And do push your full name, the organizational details, and your official email ID in order to win up this poll. There are exciting prizes for you, starting from an Amazon Echo to a Autodesk branded goodie to all the lucky winners. And all the lucky winners would be announced by tomorrow. And you could be notified about all these details when these information will be published at the below URL mentioned in the slide basically. And all the information related to the session or the information which we present in our presentations will be shared to you via the registered email ID which you have registered for this particular session in this case. Now, let's start off with when I talk about a plant project in this case. And when I talk about a plant project or an EPC project, let's start off with the critical challenges we currently see in the EPC market in this case, basically. Now, when I talk about the current industry trends and challenges which are therein, the first piece being the aging facilities and in the developed world which is therein. Now, if you consider the population growth and the urbanization, and as the world population is increasing from 7 billion, which was there in 2013, to the 9.1 billion, which is supposed to reach by 2050 in this case, basically. Now, in 2030, we might have 60% of urbanites as projected, which might be around constitute to around 47% in 2000 basically. So you might see an upscale of almost 20% in this case. The other piece is like India being also one of the developing nations, which is pushing a lot of stress on a lot of infrastructures, engineering aspects of it, and preferably all these infrastructure and plant facilities, they even continue to age in this case, basically. The next important thing which matters in this case is the emerging economies, which needs more and more capacity in this case. And when I talk about these emerging economies, the first criteria would be the urbanization of the developing world. The second would be these developing nations requiring new facilities or new infrastructure to meet their growing demands which are there. The third important aspect would be something like environmental and safety issues, which are driving these regulatory compliances in this case, basically. So it could be something like a greater utilization and output resulting in environmental challenges, or it could be the facilities which are running at maximum capacity and which could increase higher risk in this case, basically. The third criteria would be the environmental and the safety aspects or hazards or issues which are rising of these regulatory compliances which are there. And these regulations creating an impending outputs, which are again an important criteria. The next piece is the engineering and the design efficiencies, which becomes more and more critical in this case. Basically, when I talk about engineering and design efficiencies, it could be something like the demand being exceeding the supply, the budgets being scrutinized, and there are financially uncertain times which are there in case of these plant projects. The next criteria could be something like modification and a revamp of a project with respect to the tight project deadlines which are there in, basically. Or it could also take into consideration the cost which is incurred with these kind of plant solutions or plant shutdowns which are there in, basically. The next piece is the retiring expertise or the retiring workforce which is therein. The current aging workforce which is then 50% of the designers might be retiring within the next 10 years. And how do we retain these talents with specialized skills and knowledge which are very, very difficult to find and very difficult to retain as well? The other piece is the lack of the training written on investment, which also would be the current industry trends which are following in this case. The next piece is something like on to do with the system complexity and the risk factors which are therein. The consolidating plant design industry, causing complex portfolios of our softwares, which makes a technology almost obsolete in this case, or things like making the products very difficult to learn and very hard to maintain and optimize, basically. Now, how do we cater these industry trends and challenges? So let's talk about from the perspective of a plant design solution. So as I said, I will talk about the workflow from conception to modeling to optimize and coordination. Now, when I talk about a conceptual stage or a conception stage, which is therein, EPC project actually starts up with something like intelligent process flow or instrumentation, process and instrumentation diagrams, that is both P&IDs and PFDs which are there in places. Now, in order to use these P&IDs, we have a lot of specifications, we have a lot of regulations, and these specifications is what drives our P&IDs, basically. And these specification helps us to meet our project equipment specifications at a higher extent in this case. The third piece being in the conceptual stage is like, if we could remove a preliminary plant layout information for our initial cost estimation, which could make our conceptual stage pretty easier in this case. Now, when I talk about the next stage of modeling, how do we utilize these PFDs, these process engineering diagrams, P&ID diagrams in the whole engineering of our plant in this case, basically? How could our piping be exactly precise and our equipment layout actually talking out about the intelligent 3D information or the BIM information which is there? Now, in case of a project which is related to a brownfield, how do I utilize my scanned information? How do I utilize my plant cloud information to capture the existing conditions and help there, and which could help me in my design workflows in this case, basically. The fourth aspect could be, how could I utilize this 3D model which I've created to actually create plant layouts, utility infrastructures which are there and the respective site plans? The third piece being the optimization piece, basically, and where I would talk about something like talking about pipe stress analysis, the flow aspects which are therein, the structural analysis aspect of it, the steel stresses aspect of it, basically. Now, when I talk about these optimization, preferably a single solution might not cater to all these aspects of a plant design, basically. So definitely you would require to leverage a lot of intelligent BIM tools which could integrate with our plant design solution for responding to better architectural, structural, and design engineering perspectives which are there. How do I take this drawing information coming in from the solution to act as an interoperability with other analysis application? It could be a piping analysis which is therein, or it could be something related to structural analysis aspect. The last stage of a plant design solution, be talking about the coordination aspects of it. How do I link my multidisciplinary information pertaining to my plant, piping, structural, and also including my respective OOs, that is owner operators, and the respective stakeholders to take an active part in my project in this case, basically. How do I well collaborate? How do I well communicate with them, basically? How do I communicate the clashes which happens between the multidisciplinary information which I'm talking about? How do I take into care the equipment clearances, the equipment accessibility into consideration in this case? How do I utilize also the plant cloud information to use it for fabrication? Might be generating the pipe spool aspects, it could be structural fabrication, and I take care of it that I fit it properly before starting up my erection or fabrication on the site in this case. Now, while I talk about these workflow one by one, let me take you to the very first stage of conception, and let's talk more in detail with it there. Now, predominantly, if I see the market utilizing a lot of competitive tools, but this particular piece, people still utilize a CAD environment to generate their P&IDs and PFT diagrams, which are there basically. Now, Autodesk solutions uh, help us to work on the CAD environment which is there. And the beauty of our solution is it is quite intuitive, interactive, and very easy to learn, so that you get the flexibility of a CAD environment at the background while you work on an intelligent BIM tool which is there. How easy it would be in case if I have to generate my P&IDs and PFDs, that my nozzle gets placed automatically. There is a valve alignment which is therein. I could push on the industry standard symbols which are required for my P&ID, or if I could customize that standard block library of the CAD in my Autodesk solutions to easily generate these kind of P&ID and PFD diagrams. Talking about the stages, like when I use my intelligent solution, preferably I need the reporting to be done at the various stages, preferably pushing on these information which is existing at the background in a spreadsheet, exporting and importing in different formats, which could be shared with other disciplines in a form of Excel, which is therein. Checking of duplication of tags which are there, and when I am drafting my P&ID and PFD diagrams which are therein, checking out the updation of my annotation. Instead of doing a dumb annotation on my CAD drawing, why don't I use an intelligent facility to do these annotation updates which are therein? We also have these facility to connect it to different pages or different sheets of my P&ID by using the off-page connector facilities which are therein. And last but not the least, when I move from my conceptual stage, I should be able to integrate my P&ID information or the PFT information with my plant 3D model in this case, basically. Now that's a example of or a snapshot of the P&ID workflow which could be seen in, and preferably you could see the interface being quite easy. The right hand side replicates the tool palettes which are used for drafting my P&ID diagrams. At the bottom, what you could see is like Excel-like spreadsheet which tells you as to what pump are you referring to, and you also see a revision mark with the yellow highlights replicating these information and the changes which you did for that particular P&ID diagram. And these all happens at the end, at the background, by a CAD workspace at the background in this case, basically. So you're pretty much using the same CAD environment, but you're using some additional tools on the top of that CAD environment to draft these P&IDs in this case, basically. The next piece, in case of a P&ID after the conceptual stage, is the modeling stage, which I come in. And when I talk about these modeling stage, I'll very predominantly first talk about tools which are used for equipment designing, which is therein, and Autodesk has got a lot of solutions in which plant designers can utilize in order to do equipment designing, which is therein. Now, when I talk about equipment designing, preferably these equipments could also be coming from a mechanical CAD system, coming from your equipment suppliers who are using different facilities to model that particular equipment. But the beauty is, while you bring those information and equipment to the model, and if it is an actual intelligent data, you could bring in the digital information not only, as well as the intellectual property data which lies within that equipment, and it could be accurately placed in the layout of your plant design which is therein. And the best piece is you could actually remove your respective drawing layouts which is to be required to be generated, as well as reduce as much as plant design errors when you are coordinating or complying with other disciplines who play an active piece in your project in this case. When I talk about the modeling and the optimization stage after the equipment design, preferably we talk about something like piping in this case. Again, piping is driven by specs. So our solution preferably has a set of industry standard specs which could be utilized in order to do the spec driven piping which is there. And the beauty is the modeling of the piping on a CAD environment at the background with the Intuitive interface is quite easy. So it gives you access to easy editing. And the beauty is when you're editing these piping elements, the connectivity between the connected elements is quite retained in this case. It also gives you facility to do automated as well as the manual pipe routing in this case. While you're doing these manual and automated pipe routing, it also takes care of intelligent connection elements or compatible connection like flanges, which forms an important part of your piping in this case basically. And the other piece is, while you're generating these piping information or you're doing this piping model, what you could do is like you could generate isometrics. You could even generate things like a PCA file, which could be utilized for pipe stress analysis for a third-party tool, which is therein. You want to remove in information like the center of gravity reports and calculations for your elements in this case, or whether it is required to be creation of intelligent orthographic drawings which needs to be created faster and updated in your project in this case. Now let's assume a different case altogether where I was talking about the challenge in the industry that our plants getting older, and preferably we need to revamp or refurbish our plants in this case. And now when I talk about revamp and refurbishing these plants, and we have pretty number of technologies like using a laser scan survey which is therein, photographic images which are therein. How do we utilize those information coming in from our scans, stitching those scans and converting into an intelligent model which is therein. So Autodesk solutions like Recap can help us clean up these information. First of all, it could register these photographs and scanned information. It could clean up those information. It could clean up these point cloud data, and you could utilize it in tools like or in Autodesk solutions to further model that particular plant in order to retain a digital information of that particular revamped or refurbished plant in this case basically. Now, when I talk about plant projects, it doesn't end only with the a plant layout or a plant piping aspects, equipment modeling, etc. There are a lot of other things which are there, and basically, preferably our industry also has cases where we model substations, etc. For example, integrated substation design which has to be done in, which could comprise a mix of concrete elements. It could comprise a mix of structural elements, where you need to take care of things like a small lighting fixtures which are there in, categorizing those lighting fixtures into different categories, utilizing or modeling things like switches, security devices, showing up the power outlets, mechanical information, switchboards, panels, etc. It could be also categorizing that particular substations into mechanical ducts, plant rooms, showing up the air conditioning units. Now, tools like Revit, which forms a part of Autodesk solution, helps us to modeling these aspects, which are again an important part of our substation design, which is there in this. And the beauty is you could go to any nitty-gritties to model any of these information in our BIM model, which is therein. Preferably starting off with the fire extinguishing equipment to pushing on hydraulic pumps to modeling up a cable ladder and classifying that cable ladders into different categories, basically. Or routing your cables through tunnels, connecting to the GIS information, connecting to the transformers, etc. in this case, basically. So that's another example of utilizing tools like Revit to create an integrated substation design model in this case. Now let's talk about the circuiting aspects which we need to model in these substations. Now tools like Revit help us to do these power reticulations, or what we call as auxiliary power. And we have got these amazing automating circuiting feature which helps us to connect the panels and connect the circuits and display them in our drawings, which forms a part of our project in this case, basically. Or it could be going into nitty-gritties of modeling cable ladders and showing those color codes for the cable ladders, and again color coding those cable ladders and filtering those cable ladders into categories like LVAC power cables, protection cables, fiber cables, etc., and neatly representing those in the different outputs of that particular cable ladder design drawings which we require in this case. Not forgetting one more aspect of the substation or the rooms which are talking about the GIS building, the plant room in this case, in where we need to model in things like exhaust grills, ducts which are therein. The space is so constrained in this case, in where you have to be very, very careful about where do you place your substation equipments, pushing on the information related to the risers, the penetrations, taking into consideration the structural design aspect so that it doesn't collide or clash with your mechanical elements which are therein, making an alternative design options or alternative solution in identifying the plant rooms which are very, very tighter and constrained, and modeling things like split systems or fan exhaust which is therein. And last but not the least is like, while you're modeling a lot of these MAP elements, you definitely need to coordinate with a different discipline altogether, which is the structures in this case. So it should coordinate with your structural design elements preferably. Now, when I talked about concrete elements, there are a lot of elements which comes as a part of our structural modeling, which could be steel elements which are there in basically. So Autodesk solutions can help you in modeling these kind of structural elements. So we have 40 country codes which could help you into modeling these kind of structural elements. It could also model in things like the connection aspects of it. It could model miscellaneous elements like your staircases, platforms, cage ladders, etc., which form a part of your project. Last but not the least is like, you need to coordinate or you need to combine it with different tools, which could be between Autodesk solutions or which is external to Autodesk, and preferably generate a lot of structural fabrication drawing. So Autodesk Advanced Steel is the tool which could be utilized in generating the structural fabrication drawings in this. Now let's talk about a bit of detailed examples, because when I talk about Autodesk solutions, when I talk about structures, where we use tools like Autodesk Advanced Steel and tools like Plant 3D, which could integrate between each other, where we utilize Plant for doing our equipment, piping, and plant layouts, whereas in the structural piece of information could be handled very well inside Advanced Steel. Now, the beauty is these two tools can integrate via a different interoperability format like steel markup language or an XML format, which is there. And this information could be integrated or could be moved in between the two different solutions by using these XML outputs which are there in basic. Now, while you're doing this in case of a plant 3D and you're trying to bring this information into Advanced Steel has got tools which could import this information of the structure, might be the general engineering periphery information which comes from your plant 3D into tools like Advanced Steel, and you could import this information with all the intelligent elements, with all the intelligent information. That means ISMB 200, which I represent in my plant model, is retained the same as in the Advanced Steel model which is there. So I'm conserving all the properties as it is between the two solutions. Now I'll take you through a small example as to how do we integrate this in case of plant 3D. Now, as you see my screen, you could see a small plant layout where I've got a pretty amount of information related to plant layout, piping, equipments. I even have the general periphery structural elements which I have modeled in this case in basically. Now, as you all know, the plant project gets divided into different categories. What I could do is like, I could take up the structural information uh, from here to tools like Advanced Steel in this case, and I could export into an XML format, taking up into consideration all the structural objects. What I could do is like, let me save these information first. I could select all the objects, that is all my structural objects, which forms a part of that particular piece or zone of the projects, and I could take up it into Advanced Steel in this case. Now, while I am doing this, what I could do is like, I could launch an Advanced Steel and import this information by using the advanced import facilities, where I could bring this information of the structure coming from plant 3D into Advanced Steel. Now, what it does is like, I bring the same XML file and we could see that it retains our respective properties and information which is there, and preferably I could change into the different modes and show you the properties of each of these elements basically. The next task is that how do I take care of these information which is exported from plant 3D to Advanced Steel, and what do I do in Advanced Steel in this case? So the Advanced Steel information, the information which you imported inside Advanced Steel, could be copied to a plant 3D project. I mean, you could detail out those elements in Advanced Steel and preferably connect via XRF reference, which is a typical CAD way of working in, and then integrate into tools like plant 3D in this case. So what I could do in is like, let's detail out these plants. When I talk about detailing out of these plants, I could create some connections which are therein. I could show you how the properties of that elements are retained. I could change out categories of the positioning of the element. I could change information related to the material properties of that element, the grades of the steel which is required to be changed in basically. And while I am doing all these aspects which are there, for example, doing a typical connection details which forms a part of our project which is therein. So I could add additional concrete object, preferably a base plate which has to be done in. I could customize the properties of that particular base plate which I am trying to model up, preferably typical beam and column connections, which could be shear plate connections, which I want to generate between my primary members and the secondary members in this case, basically. Adding in information related to the number of bolts, the diameter of my holes which are therein, what should be the number of bolts in the vertical, horizontal direction, intermediate distances between the bolts. All those information could be taken care in this case, basically. And for example, I could even model typical miscellaneous elements like handrails or cage ladders for your information in this case, and detail it out further, basically. So I could have a quick a hand railing which I modeled in this case, basically. Now what I could do is like whatever I detailed out in advanced steel, I could make it as a part of my Plan 3D project in this case, basically. So let me go to my Plan 3D project and preferably call up that category or that zone of the detailed information into my whole of plant project, which is there in basically. So let me copy that particular information to this particular project as it forms a part of my plant project. And you could see that I brought in the information into my plant project, but let me lay out these information. And you could see that it brings in all the information like my connections, the handrails which I placed in basically. And what I could do is like just extract that piece of information back into my plant model basically. So let me attach that file. And you could see that that particular model being added as a part of your project, all your information forming a part of your plant layout. I could also show you the base plate which we placed in this case basically. So that's how you could integrate tools like Plant 3D and Advanced Steel, which forms a part of Autodesk solution. Let's come down to the next piece of information which is there. Now I'll talk about something like coordination. Now, integrating between plant and the structural solutions is one piece of it, or integrating with the mechanical, electrical, plumbing elements, or showing up cable trays, ducts, etc., which could be taken care in Revit. Now, all these disciplines working in silos or coordination needs to be coordinated. How do we coordinate it? Preferably, we could utilize tools like Navisworks or Navisworks Manage in this case to create a quick class check, create a quick report in this case, create a quick walkthrough or a fly through my plant project in this case, annotate that piece of information, comment on that, create markups on that, or measure that particular piece of information for the project reviewing purposes. I could go one step ahead. I could create a clash detection report. It could be in the form of a PDF, HTML reports in this case, which could be assigned or which could be shared to the respective disciplines who form a part of my project in this case, basically. The next piece is the construction planning piece of it, basically. When I talk about construction planning, in order to plan our projects, you might have data of a plant project which is into planning stage, lying in your Excel sheets, lying in Primavera, lying in Microsoft Project, etc. How could we import these information? So we could bring those information from these tools and connect it with our plant elements, which could do a visualization or a simulation of our plant project, or a typical 4D visualization of a plant project in this case, basically. So Navisworks could take care of all these information while you're doing the project collaboration and the visualization of my project in this case. Now, what I could do is like, let's go through a small video as to whatever we talked about on a plant solution in this case, basically.
These plant design environment. Engineers and designers need to design, engineer, and construct plant projects efficiently. The Autodesk AEC Collection has all the tools you need. For the design of a water treatment plant, Revit can be used to create the facility that will house pump and treatment equipment. AutoCAD Plant 3D is the primary tool for the design and layout of the process plant. It is used to define the process requirements for the water facility and will use AutoCAD features to define the process database behind the schematic drawing as the drawing is being created and edited. The piping model is a 3D representation of the P&ID, and the data can be accessed while we are creating the piping. The modeling tools in Plant 3D allow teams of designers to quickly lay out equipment, route pipes, and ensure proper connectivity. Once the equipment has been modeled, we can combine the Plant 3D model with a Revit building to create the piping support steelwork with the aid of fully automated steelwork connections. Utilizing a federated Navisworks model, the project team can collaborate to detect and manage clashes between the pipework and supporting steelwork, as well as the remaining structure and services. At any point in the project lifecycle, an InfraWorks model can be created to help project stakeholders better understand the progress of the whole project, including the building and equipment creation, together with the many other various disciplines as they progress within the wider context of the project environment. The Autodesk AEC Collection provides plant designers with a rich set of tools across the project lifecycle, so you can deliver plant projects on time, on schedule, and on budget. These plant design.
So as we went through the whole set of information on how the challenges are, trending the plant industry, we saw the workflow piece of it. Let's talk about how could BIM benefit for the plant design piece in this case. And what I could do is like I would talk about how our Plant 3D and Revit customers are pushing on the value of BIM and how are they utilizing these BIM value in their whole plant project life cycle in this case. Now, the very, very first advantage of BIM when I talk about is like how do we enhance the communication between which happens between the owner operators, between the design engineering firm and the other stakeholders which are therein. So that's a beautiful example from one of our organization called as Suyapi Engineering, who uses Revit as well as a combination of Autodesk, Plant 3D, Navisworks, and other solutions from the AEC vertical to push their first BIM-based water treatment plant in this case. Now let's go to a different example altogether, where we are talking about, delivering an offshore project, or it could be designing these oil rigs, which should be very, very accurate, and it should be, running up, and it should be, very efficient, very productive, and it should be of a best quality in this case, basically. So we've got these a snapshot from an organization called as RDS, which uses Autodesk Plant 3D solution in order to model the oil rigs, basically, and they are utilizing and empowering themselves by using the power of BIM in this case. The third important criteria of a BIM when I talk about using BIM for plant design is reduction of errors. So reducing the errors as much as possible in case of plant projects. Now, error reduction could happen only when you utilize intelligent tools like BIM solutions in order to manage your project, in order to simulate in your project, in order to visualize or imagine your project in this case, basically. So that's a beautiful example from one of our customer called as Albor Energy. They have used our BIM solution in order to model and design their biomass plants in this case, and they've used a solution called as a Plant 3D for designing these biomass plants in this case. The next important, the fourth important criteria is when your projects are quite big, and what you need to do is like you want number of people to work on your project, and you utilize all the features of your BIM tool which you're utilizing in this case. So this company, which is called as Process Pipeline Services, they've utilized BIM solution for their natural gas designing perspective, and they have made it sure that the plant 3D tool which is there, it is accessible, or it could allow people to work, 2 or 3 people to work simultaneously on the project, and also taking care that they utilize all the features of plant 3D in this case, basically. The fifth important point is of BIM is like, I need a more accurate documentation of my BIM project, which is there in basically. And when I'm generating these accurate documents, the inaccuracy or my information, my model and my drawing should be completely accurate, and it should be quite lower in this case, in case if it is inaccurate. So we've got a beautiful example from Delta Group, which is there, and what they have done is like they've designed the entire unit in 3D, and their main advantage or the testimonial which we have received from them speaks that the inaccuracy or the risk of inaccuracy is quite lower, hence managing accurate documentation with BIM solutions in this case, basically. Let's come to a very different example where you want to utilize one of the advantage of BIM in case of projects which are involved into brownfield or reverse engineering piece of the project which is there, and you've got huge amount of scanned information which is there. So Autodesk Plant Solutions has helped the organization, that is Chahu, in order to convert their 3D scan mesh data into intelligent model. And what they could achieve is like, while they're utilizing this mesh scan data to convert it into intelligent model, they have pushed up a reduction in the time. So they have almost got a time saving of almost 50%, and their process time has got much reduced by almost at 70% in this case. So that's how you could utilize the intelligent 3D scan data and mesh data in order to do a reverse engineering of your plant project in this case, basically. The next example is one beautiful example which is there, where we talk about efficiency, which is there. And when I talk about efficiency doesn't only mean that you save on hours. It also talks about how I reduce my issues, how I reduce my errors in my project, not too much of conflicts with the other stakeholders who are working. So Atkins, for their water plant expansion project, wastewater plant expansion project, utilize the Autodesk BIM solution in order to achieve these perspectives, not only on the aspect of time saving, but also in the aspect of reducing these number of errors on the project, basically. Everything is right in case when I talk about the advantage of BIM, but what if it doesn't give me cost saving? So that's the advantage of my BIM, where it gives me significant time and cost savings which are there. Again, an example of a water treatment plant which is there, coming from Atkins once more, and how they have utilized Autodesk solutions for improving their constructability and providing more efficient operations and maintenance in this case, basically. There's one more which talks about the cost savings and the improvement part, where apart from the plant solutions, they've also utilized tools like Revit, and a design issue sometimes is so expensive that it could cost you cost Mott MacDonald approximately more than $1,000 in this case. And now they have reduced that particular criteria to almost 1/4 of the cost. So giving them a significant cost saving aspects in this case, basically. Now, a different aspect of a BIM altogether, where we talk about coordination. When I am coordinating with different geographical location, different disciplines, and different offices which are there in. Now, utilizing tools like BIM 360, utilizing Autodesk solutions, etc. They were able to better collaborate on their design, uh, better communicate on their design with using BIM solution, thereby increasing the efficiency, reducing the time, saving their times which are therein, and also expensive money, which also forms a critical part of the design and construction aspect in this case, basically. Now, whatever I talked about on the workflow, customer success stories, I pitched upon a lot of solutions in this case. Now, whatever I spoke about, so in case if you are a multidisciplinary engineering firm, which want to take the leverage of the whole of BIM solution, Autodesk has simplified it by different collection. One of the collection being Autodesk AEC collection, or Autodesk Architecture, Engineering and Construction collection, which gives you the power of the CAD tools like AutoCAD Mechanical, AutoCAD Plant 3D, etc., and also taking into consideration the BIM aspects of modeling, structural, concrete elements, fabrication information, utilizing tools like Revit, InfraWorks, Navisworks, vehicle tracking, etc. So all these solutions forms a part of the AEC collection. So that's one single solution for your entire plant project in this case, basically. If you want to learn about Autodesk BIM, especially for plant design, we already have a section on our website which could help you provide more information about plant design. And apart from our solutions like AEC collection, you could also learn more information about our other products which forms a part of AEC collection, like AutoCAD Plant 3D, which is also available as a part of AEC collection, which is also available as a part of one AutoCAD toolset, which is therein, or talking about Revit 2020, which is therein. So visit our website, where we talk about what has been added newly to all these solutions which form a part of AEC collection, and you could predominantly see the new features of these solutions as well, basically. So now is the time for Q&A. What you could do is like, I have completed my presentation. Be open up and free to post your questions on the chat box, basically. So you are free to type your questions, or request you to push your questions in the chat box, please. Please type your questions in the chat box. Okay, so as there are no questions, what I could do is like, I will launch up a poll, and preferably you could specify these information while you launch the information on the poll in this case, basically. So I've got a huge audience, and preferably I would request you to vote, because there's still, 40-45% of the people who have not voted, basically. So please do vote in the poll. So we almost have 40% who have not voted in the poll. Request you to please vote on the very first question in the poll. Okay. So what I could do is, like, let me push on my second question for the poll. Request you to please vote. Okay, so while you are replying on the poll, what I could do is, like, I could answer a few of the questions which has come in from the attendees. Basically, the first question talks about the file should be coordinated with a smart plant 3D in this case, and the answer to this is, like, the information which is coming in from Smart Plant 3D is, like, I was talking about Autodesk Plant Solution, but what you could do in this case is, like, if you're more into coordination and collaboration piece of it, you could take up the VUE file which is coming from Smart Plant 3D, and there is a Smart Plant app which is there, which needs to be installed on the top of Navisworks Manage, which can help you to do these coordinations, basically. So you could bring the VUE file directly into Navisworks, and you could do the class checks in your project which is therein, and preferably it also retains the information which is coming in from the Smart Plant 3D tool in this case, basically. So there's a next question which is talking something like, the question is PCF import and export, how it works in this case. So what we could do is, like, if you go to Plant 3D, in the sections where you generate your isometrics, there's a small tool where you could generate a PCF export. So you could create a PCF export, and that could be utilized for interoperability, in case if you want to do integration with pipe stress analysis tools, etc. You could send those PCF files coming in from the softwares, could be also done. And so if you bring tools information or PCF files from tools like Caesar, etc., so that could be bought inside Plant 3D as well. And basically, now there are questions like cable trays, etc. And when I talk about cable trays in this case, cable trays is better to be modeled inside Revit. And Revit itself has a wide range of Revit families which could instigate in helping you out in designing or modeling the cable tray aspects which are therein. And in case if you want to understand how this has to be done, please feel free to communicate back to my marketing team on, in case if you want us to get in touch with you in this case, basically. So there is something coming in from a question like, there's a visitor who has visited our AU sessions, which are therein, and and they're asking whether the Plant 3D aspects would come down to Revit. We need to understand one thing in this case. When I talk about modeling of the piping information and modeling in the equipment information, which forms a major part of the plant project, as well as I compare it with the utilities which you model in commercial structures of plant, etc. Those are different categories of piping. So you might not see things like the Plant 3D features getting merged into tools like Revit, because these are two separate solutions. And when I talk about these two separate solutions, these separate solutions can get integrated with each other in this case, basically. So Plant 3D and Revit will coexist with each other. What we are trying to do in further is like bringing up more and more collaboration features which could integrate from Revit and Plant 3D to the cloud in this case, basically. There's a question that Revit and Plant 3D is still in manual DWG conversion process. I did not get the question. What does he mean in this case? Basically, what I could do is like I could go to the next question, which is there in basically. So there are some questions which are coming about Bentley Autoplant. Can Plant 3D integrate with the Bentley Open Plant or Autoplant, which is there? Yes, we could integrate. You know the Bentley auto plant data into Plant 3D, and meanwhile the specs which are relevant to tools like Open Plant or Auto Plant or CADWorks in this case could be converted into the spec facilities which are there inside Plant 3D. So we have that flexibility of spec conversion and connecting it to Plant 3D in this case. I do not know what this question means, but it says that can we create a central file in AutoCAD Plant 3D? Our central file is preferably a concept which we use in Revit, where the other stakeholders or the participants who form a part of the Revit project actually integrate with their piece of information to the central model file. In case of Plant 3D, works a slightly different. It works in a case of a project format, and in the project you could have unlimited zones, and these unlimited zones could be divided into different number of people. Ultimately the scenario is it works on the same common project, so you could say that it's not a central file, but it's the same project in this case, basically. So there's a question which talks about integrating Plant 3D file in Revit, basically. Now, the answer to these is if it's a structural information which you're trying to integrate into Revit, then it could be integrated via the format called as SMLX, which is, and for doing this import in Revit, you definitely need to have extension or add-in which is called as advanced steel to do it. And the other ways of integrating the equipment and the plant model could be in the form of a DWG file which could be integrated inside the Revit model which is there, basically. We are working on Revit for pharma facilities. Can we integrate the piping completely in Plant 3D with Revit? The answer is yes, but in order to simplify the workflow, you could utilize the tool like Navisworks, where you could integrate both the tools which are therein, basically, and bring in the information both from Plant 3D and Revit and integrate it as well, basically. I did not get this question, but we need to develop 3D models for substations in AutoCAD Plant 3D. modeling of a substation is not only mechanical equipments and plant elements. When you're doing the substation modeling, you require a lot of categories of lighting fixtures, cable ladders, exhaust grills, concrete elements, structural elements. So you cannot do it with a single solution. You definitely need to go with a workflow in this case. And so it's better to go with the AEC workflow instead of integrating a single piece of tool to do all these things basically. Okay. I have still repetitive questions on how PCF import works in. Preferably, you could connect my team again, and you could search up in the knowledge forum as to how PCF import works in Plant 3D in this case, basically. So there are questions like how we could use Plant 3D instead of another software like Civil 3D and Revit. Now, Plant 3D is specifically for plant modeling, plant piping, and plant layout. And none of our tools like Civil 3D is specifically meant for infrastructure facility. Revit is meant for, the concrete, steel modeling, architectural piece of it, MEP piece of it, basically. None of these solutions clash with each other. All these solutions can coexist and will coexist as a part of whatever engineering workflow which you're trying to deliver in this case, basically. Okay, so there's a question as to Plant 3D requires some sort of support files before opening up any kind of project. Yes, because Plant 3D works on something like specifications and catalog. Definitely, while doing a plant model, you will require all these kinds of information to model your plant project. That's the reason it takes into consideration all these specifications and combinations at the background, basically. Again, coming up a central file, we don't have a concept of a central file. We could divide your plant project into zones and work on that particular piece of the project. I will answer the last few questions. There's a question on where do we model plant projects. I could say that you could use a combination of Plant 3D and Revit to model plant projects which are there in this. One last question which is there and which could talks about how do we integrate data coming in from Plant 3D to Revit like schedules and P&ID. To integrate Plant 3D's P&ID with Revit, basically, there is something called as a P&ID add-in tool which sits on top of Revit and which could integrate the data coming in the P&ID format from Plant 3D to the P&ID piece in Revit, basically. What I could do is like, we already have a lot of information on the knowledge forum. In case when I present my next webinar, I'll take care of it that I showcase that particular piece of the workflow of P&ID integration between the two tools, which is there. There are questions that we use Revit MEP for modeling in, basically. The plant industry works in a form of spec catalog. If you are doing piping layout and modeling for a typical plant project, use Plant 3D. In case if you're into projects like commercial projects, airport infrastructure, where the MEP aspect is different, basically. So there you need to use Revit in this case, basically. And ideally, the two industries and the two verticals are different. So be careful where you're utilizing the two tools. And the two tools are meant for two different purposes in this case, basically. I believe that's the end of the questionnaire which is therein. And what I could do is like, I believe the polls have been also completed. And what we could do is like, let me close this and let me end my session. So thank you, and keep yourself awaited for the results on the poll, which will be shared tomorrow on our website, basically. Thank you.